Hello and welcome to another video lab. I appreciate you being my lab partner in this strange situation of how we do labs. But the purpose of today's lab is to make a compound in lab, take some data with that compound, and then figure out the empirical formula. Now, you need to have the lab handout. So if you've not already done so, you need to download this handout so that you can take the data with me. You'll be able to see then the purpose of the lab, our essential lab question, which is what is the empirical formula of the lab compound? And then there's a place for you to do your hypothesis. The big idea for this lab is that we are taking magnesium and we are going to get it so hot, so add so much energy that the magnesium atoms combine with the oxygen atoms in the air to make a new compound. So a synthesis problem, that's what we're going to be creating, or that's what the experiment part is. And then we're going to take some data along the way so that we can eventually calculate the empirical formula. So that's the main idea. So because we know that it's magnesium and oxygen combining, we can actually make a hypothesis and predict what the empirical formula should be based on oxidation numbers. So why don't you pause the video and do your hypothesis, make your prediction of what you think the empirical formula should be, or the compound formula should be for magnesium and oxygen, and your because is going to be because of your oxidation numbers. So pause the video, do your hypothesis. All right, welcome back. So assuming you've done your hypothesis, you now have a prediction of what that compound should be, and then we're going to take experimental data, test that hypothesis, which is a very normal thing in the experimental or scientific world. Okay, so you can see the procedure is spelled out for you. The list of materials is there. I'm going to kind of be walking you through steps. I'm going to try to show you with my laptop camera some of the things that we're seeing. I don't know that I will be in the video the whole time, so if I pop out of it and you can just see my hands, that's fine. Just keep working as if you were my lab partner standing next to me. Here we go. So the first thing I'm going to do is I'm going to set up my ring stand setup. So I've got a ring stand here. So I'm going to put a metal ring on it. And the metal ring will hold my system. All right. Okay, so I've got my ring there, and then I'm going to put the Bunsen burner underneath it pretty close because I want to heat this pretty strongly. I might move it up a little bit. And then I've got a clay triangle. That clay triangle is on the ring. That will hold my crucible. And then that's all. I'm going to use a watch glass as a cover. All right, so on your lab handout, find your data table because you need to record some information with me. All right, so the first piece of information that we need is the mass of the empty crucible and the watch glass. So I'm going to put those together. I'm going to go over here to my balance and make sure the balance is zeroed out because I just want the mass of these things. And I put that on there, and I get a mass of 35.31 grams. I'll go ahead and show that to you so you've got that there. Oh, goodness. Okay, there we go. Sorry. All right, so 35.31 is the first mass that we will record. All right. Then I need to get one of my reactants in my crucible. I'm going to clean off the magnesium using this piece of steel wool. It sometimes gets some oils on it or some dust or some particles from like the container. And I just want to try to clean it off as best I can. I might not get it perfect because I'm going to have to actually touch it again, but this will kind of put it back to, kind of the square one. So I'm just kind of polishing it. I'm getting anything off of it that I can. And then I'm going to make a flat coil so that this will fit inside my crucible. So a coil, meaning that, kind of like a spring, only it's flat. So I'm just kind of wrapping it around. Yeah, I know, I just cleaned it. Now I'm touching it. That's just kind of what we have to do. So this is what I mean by a flat coil. So flat coil. And then now that will fit in my crucible. And then now my second mass that I need is the watch glass, the crucible, and the magnesium strip. Again, I make sure my balance is zeroed out. And then I put this on top of there. And again, or not again, but the mass should have increased, which makes sense. It did because I added something to it. So 35.75. That is my next mass that I need to record. 35.75. 0.75 grams. All right, now I'm ready to make this reaction happen. And what I'm trying to do is I need to make it so hot inside this crucible that the magnesium atoms will combine with the oxygen atoms. But the tricky thing is that if I just leave the cover off, I'm not going to get very much oxygen in there, only the amount that's sitting in there right now. But if I leave the whole that's if I leave the cover on. If I leave the cover off, there will be a lot of oxygen that can get in, but it won't get very hot. So what I'm going to do is I'm going to kind of balance the crucible off to the side, making a little crescent opening. So I'm going to put that on there, and then I'm going to kind of just slide the crucible off to the side. You can kind of see what I did there. And then that will allow an opening so that I can get some oxygen in, but then keep in a lot of heat. All right, so I'm going to turn on my gas. Maybe you can hear that. And then I'm going to light my Bunsen burner. And then I'm going to make sure this is as hot as it can be. Can you hear that? It kind of sounds like a jet. All right, so then now this is the waiting time. So what I'm waiting for is noticing any sign of a reaction. Like if there's any sparks on the magnesium, that would be light given off. That's a sign of a reaction. Or the magnesium might start to turn a little bit ashy. That shows me that the reaction has started. In fact, can you see in there? Do you see those little sparks? So that shows me that the reaction has began. So now what I'm going to do is I'm going to keep giving the reaction some gulps of oxygen, but I don't want to keep the cover off for too long because otherwise that will cool it down. So I'm going to take it on and off, on and off. So I'm going to give it a gulp of oxygen, and then I'm going to put the cover back on. And then I'm going to give it a gulp of oxygen and put the cover back on. And I'm going to keep doing that off and on until I don't see any more glowing. Now, when I take this off, are you noticing that there's a little bit of vapors that are escaping? That's some of my product. So that's another reason I don't want to keep my cover off for very long, because that can contribute to some error. So I keep doing this kind of on and off thing, on and off, until I'm pretty sure the reaction is done. And again, I'm going to know the reaction is done when I take the cover off and there's no more sparking or changing anything to my reaction. And after I finish with this part, I'll hold the computer up again so you can see what it looks like inside there now. All right, so it still seems to be doing some sparking. Kind of a bunch of little sparks in here. Looks like it's pretty good. Definitely I'm making a product. I can see light being given off like I showed you at the beginning. And then I also see that the product has, the reactants have changed color. It's kind of like a whitish ash color now instead of that silver metal color that it started with. Just trying to check to see if this is done reacting. I'm still getting a little bit of spark, so I'm going to just let that keep going, keep going. A little bit of sparks are still happening when I take the cover off, because I want to make sure that the magnesium reacts completely, like make as much product as possible so that I can get the best data as possible. Make sure that keeps going. Okay, I'm going to let that kind of sit there, and I'm going to try to show you what it looks like now. You can kind of see in there, see how it looks a little bit different, kind of ashy. All right, let me check it again. See if we end up with, so a little bit of sparking is happening. So letting all the magnesium react with as much oxygen as it can. And then again, I keep giving it gulps of oxygen to see if it needs it to keep making the product, keep making the product. That looking good, looking good. Okay, so then now I'm going to turn the gas off, and then I'm going to let this I'm going to let the system cool. So I'm going to do a little time lapse. So pause here. Okay, so this is cool to the touch now. So so now I'm ready to get my last piece of data. I'm going to first show you what it looks like in there. So remember what it looked like when it started, and now we've got this ashy product now. So I take my watch glass, my crucible, and my product. I put it on the balance, make sure the balance is zeroed out so that I get the mass of all of this. All right. And then I get my last mass for my data table. And it makes sense the mass did go up because think about what you did from when when just the magnesium was in there. Now oxygen has been added. So 35.93. And then I'm ready to, that's it. I have all of my pieces of data. So now I can analyze the data to try to figure out how many grams of each reactant did I use. And then remember, you're trying to find empirical formula. The definition of empirical formula is lowest whole number mole ratio. You already will have grams from your data about grams of your two different reactants. So you can turn to moles, do some math tricks, get the lowest whole number mole ratio, and then you're going to compare that to your hypothesis, which should be a ratio of 1:1, and then you're going to actually calculate something called percent error to see how close you were. All right. So when you start thinking about explaining your results, so in your CER conclusion, the reasoning part is where you explain your results. The first thing you should be talking about is what reaction happened? How do we know there was a reaction? What does it mean that there was a chemical reaction? So that you can talk about getting data for your product, and then you'll also explain empirical formula, because that's the stuff that leads to our answering our EQ of what is the empirical formula of the lab compound. All right, so for cleanup, I'm going to wash the watch glass. I'm going to take a dry paper towel and dry and clean out the crucible, and then I'll put everything else away. So I'll do that while you go work on your lab report. Thanks for being my lab partner. Bye.